Assalamualaikum everyone. I'm Rabia Akhtar Joya.
And I'm Amatullah Bashira from SE department.
Today's topic of our presentation is hashing with collision. So let's start without delay. Before we know hashing with collision, we need to know what hashing is. So hashing is the technique to convert a range of indexes of an array. For hashing, the value given is to be converted to array index. This conversion is called hashing. For example, if we want to insert 500 here, first we need to convert it to array index. Here the 500 array index is 4. So we will insert 500 in the number 4 index in the hash table. Similarly, we can search for any key value. In hashing, for insert and searching, time complexity is order of 1 because we will restore and retrieve the data at the constant time. Now the next question is, what is hash table? Hash table is a data structure whose stored data is an associative manner. In a hash table, data is sorted in an array format. Now let us know with an example how to insert and search in hashing. Here we can see that the array size given is 10. In this, our array index will be 0 to 9, and the values that we need to insert are 24, 52, 91, 67, 48 and 83. First, we will create an array index by looking at the array size, then we will find the array index of the values. Now the question is, how do we find the array index of the values? With the help of this formula is k mod 10, we will find the array index of these values. So using this, if we mod the first value 24, 24 mod 10, the array index will be 4. Thus 91 index is 1 and 52 is 2. In this way, we will find each value in array index and insert the hash value in that index. In a similar way, we can search any element. Now the next topic is collision. And what is collision? The situation of collision occurs when more than one key is mapped to the same location of hashes. In this situation, two or more data elements quality be mapped to the same location in hash table. For example, here 24 array index is 0, 90 is 1, 38 is 2 and 44 is also 2. If we put 44 index 2, we can see that already 38 is in index 2. Now 44 wants to sit in this index, and if we want to sit two or more values in one place, we can call it a collision. Now, how do we handle this collision? There are two ways we can handle this. One is open addressing and another is separate chaining. Now, what is open addressing? Open addressing search the array some systematic way for an empty cell and insert the new item there if collision occurs. For example, here array index of hash value is 7 is 1, but already hash value 5 is located in array index 1. So in this case, we have to find the next empty space and insert 7. Here the next empty space is array index 3, so where we will insert 7. Now come to the separate chaining. Separate chaining creates an array of linked list of words so that the item can be inserted into the linked list if collision occurs. For example, where 24 array index is 0, 90 is 1, 38 is 2 and 44 is also 2. If we put 44 in the index 2, we can see that already 38 is in index 2. Now 44 wants to sit in this index. According to the rules of separate chaining, we will insert 44 in index 2 by creating linked list. Now I will talk about some of the disadvantages and disadvantages of separate chaining. So one is deletion is easy in separate chaining, and another, for the best case, insertion and searching time complexity is order of 1. But in worst case, the time complexity is order of n because search and insert time depends on collision. If there is more collision, it will take more time to search or insert. If there is less collision, it will take less time to search and insert.
Now I will discuss the three types of open addressing method. These are linear probing, quadratic probing, and double hashing. Now, if I talk about linear probing, it's a hash table which a collision is resolved by putting that item in the next empty place in the array following the occupied place. If I want to be clear, if we get a collision, suppose the collision is in the x position, then we will go x plus 1, x plus 2, x plus 3. Thus, when we find an empty place, we insert our element, and in this process, it's called linear probing. Here is an example where we can see that the array index of value is 6 and 16 is the same, and both index number is 1. According to the linear probing, we will not insert 16 in the index 1, but we will insert 16 in the empty space after that. The next empty space here is index 3. So we will insert 16 in the index 3. Then we will discuss about quadratic probing. In quadratic probing, the step is square of the step or square of the step number. If index is x, the prob goes to x plus 1, x plus 4, x plus 9, and so on. In quadratic probing, it eliminates primary clustering, but all the keys that hash to a particular cell follow the same sequence is trying to find vacant cell. Now, the last method in open addressing we will discuss is double hashing. Double hashing works on a similar idea to linear and quadratic probing. After the first hashing, if we get a collision, we have to do hashing again, and this makes things random and more scattering. Now, if I say there are three of these in short, for next one, it is linear probing, jump or square quadratic probing, and using hash function for next one is double hashing. Now, I discuss how to delete a record in hashing. If you want to delete a record in hashing, first you have to empty that space and fill in that empty part with a special character. Because if the record that I have deleted is completely empty, then it is difficult to search. And when we go to search, if an index is found empty, then the user stops searching even though there are more elements ahead. Here we see that index 4 we have to delete. When we delete it, in this place we insert a special character. Now I will discuss hash function quality. So hash function must be simple and it's computed quickly. Speed triggers if hash function is slow and the key value may be random or not so random. Now a question may come to our mind is between open addressing and separate chaining, which one is most usable? So the answer is open addressing is most usable because it it is easy to implement. Now the next question is when we will use open addressing and when we will use separate chaining. The answer is when array size is large and number of items less, we use open addressing, and when we don't know the number of items, in this situation we use separate chaining. So that's all about our presentation. I hope you all like it. Thank you for watching.